Hello ladies, it's Mr. O'Sullivan. Today we're going to be looking at lesson 3-3, more graphing equations of lines. Now the reason why I'm saying more graphing equations of lines is because we're going to learn how to graph lines when they're not in slope-intercept form. So today's learning target is I can use my calculator to graph a function by examining the y-intercept and the slope. Again, we're going to use the calculator to verify our answer, and we're going to do that in person. We're going to do most of these by hand. Now remember, in order to graph your linear function, your equation must be in slope-intercept form. And we know slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. Now, step 2 says you're going to identify your slope and your y-intercept, and then boom, you're going to graph it. If you want to use the steps from yesterday, which are the exact same, just worded a little differently, you can use those steps. They will still yield you the same answer. Now down here we have a table of values. Since we're graphing these by hand, we're not going to use the table of values, so let's just go with it. Number 1 says y equals 4/5 x plus 2. We have to ask ourselves if that's its slope-intercept form, and it is. So m is equal to 4/5. So my slope is 4/5. So that means I'm going to rise 4 and run 5. And then my y-intercept is 2. So I go to my y-axis, and I'm going to plot a point at 2. I'm going to go up 4 and to the right 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. So I have 5, 6 that I'm going to plot. Now, I ran out of room already. You're going to run out of room pretty quick with these graphs. I go back to my y-intercept, and I'm going to go down 4 and left 5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. And I plot a point at -5, -2. And now that I have my points plotted, I can connect them using a line. Good, just making sure the audio's on. Pretty good if you ask me. So now we can say y equals 4/5 x plus 2. Now we can use the calculator to enhance this just to see it visually. So I go to y equals, I type alpha, y equal, enter. And I do 4/5 x plus 2. And now I'm going to hit graph. That looks very similar to the graph we just plotted. Now I'm going to hit second graph. And if you look at -5, I get -2. Let's see what we get up here. Very good, I get -2. So -5, -2. What do I get at 0? I get 2. And then what do I get at 5? I get 6, which is exactly what I wanted. So that's what you would do to check your answer. To see if you did your plotting correctly. You just type your equation into y equals, graph it, then hit second graph to look at your table of values, and then you verify your answers that way. Okay? So now for number 2, we have y equals 5/4 x minus 2. The first thing we're going to do is we're going to identify our slope. So our slope is 5/4. So I'm going to rise 5, run 4. My y-intercept, though, is not a +2. It's a -2. So I'm going to plot my point at -2. And now I'm going to go up 5, right 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So I'm going to plot a point at 4, 3. I'm going to go up another 5. 1, 2, 3, 4, 5. Ooh, I run out of room. I'm up here, which is off my grid, so I can't plot any points above. So I'm going to go to back to my y-intercept now. I'm going to go down 5. 1, 2, 3, 4. Ooh, I ran out of room again, so I can only plot 2 points on this graph. I'm just going to go ahead and connect them. Not that good, actually. Let's see. Not sure what's going on here. And now I write the name of my graph. Y equals 5/4 x minus 2. And that's my answer. And again, if you want to check your answer, you just go to y equals and hit second graph. Number 3 and number 4. What's different about these equations? Well, if you look, these aren't in slope-intercept form. These are in standard form. So we're going to have to do a little algebra to get them into slope-intercept form. So the whole goal is going to be to isolate your y. Not your 4y, my apologies, just your y. What the heck is going on? Your y. So this is going to require algebra. So when we do these, we're going to be solving for y. So if I look, I have the equation 3x plus 4y equals negative 12, right? So I'm going to go down here. So I have 3x plus 4y equals negative 12. I'm going to go back up to double check. Yep, that's right. So I want to solve for y. If I look, I have a 4 attached to my y, so I can't touch that. But I have a 3x over here that's positive. What I'm going to do is I'm going to subtract 3x from both sides of my equation. So I have 4y equals negative 3x minus 12. Now I'm going to get rid of the 4 attached to my y by dividing by every single term. So I have y equals, we're going to keep fractions as fractions, so I'm going to leave that as a negative 3 over 4 x. And now I go to my calculator, I do negative 12 divided by 4. Negative 12 divided by 4 is not a positive 3, it's a negative 3. So now I can graph it. So I'm going to copy and paste this. Copy, paste. I'm going to put it up here, that way we know what we're graphing. If I look, I can identify my slope. My slope is negative 3 over 4. And my y-intercept is negative 3. So I'm going to go to negative 3, which is right here, and plot a point right there. Now I'm going to go down 3, right 4. So 1, 2, 3, 1, 2, 3, 4. And I plot a point at 4, negative 6. I ran out of room, so I'm going to go back to my y-intercept and go up 3, left 4. 1, 2, 3, 1, 2, 3, 4. And I plot a point at negative 4, 0. Now I can connect my points using a straight line. And that's your equation. And you can write it as y equals negative 3/4 x minus 3, or you can write 3x plus 4y equals negative 12. Both 100% acceptable. Now, for the fourth one, we have 2x plus 5y equals negative 10. If we look, our equation is not in y equals mx plus b form, so we're going to have to solve. I get rid of my 2x by subtracting by 2x, because I want to get this 5y by itself. So subtract 2x, subtract 2x. I get 5y equals negative 2x minus 10. And then I divide every single term by 5, because that's the number attached to my y. So I have y equals negative 2 over 5 x minus 2. This is what I'm graphing. If I look, my slope is negative 2 over 5. So I'm going to go down 2, right 5, and my y-intercept is negative 2. So I'm going to plot a point at negative 2, and I'm going to go down 2, right 5. So 1, 2, 1, 2, 3, 4, 5. Plot a point at 5, negative 4. Now I'm going to go back to my y-intercept. Instead of going down 2, right 5, I'm going to go up 2, left 5. 1, 2, 1, 2, 3, 4, 5. And I plot a point at negative 5, 0. And now I connect my points using a nice straight line. And that's it. 2x plus 5y equals negative 10. If you have any questions, email myself or Ms. Townsend. And don't forget to work on your graphing Delta Math homework.